One of the puzzles of economic history is why the Industrial Revolution began when it did and why it began in England as opposed to someplace else around the world. We saw in chapter one that Britain was not really richer than, Italy or even China um, in the previous, over the previous 500 years. And so what was going on? And so one of the hints is that wages relative to the cost of capital in Britain were higher, and that a lot of that is because the cost of capital was lower, right? So we already saw that the cost of coal became cheaper. And so this graph just shows wages in England versus France from 1580 to 1820. You can see they were a little bit higher in France up until about the middle of the 17th century, but then they started becoming significantly higher in Britain. And if we look at wages around the world, we can see that around the time of the Industrial Revolution, wages were much higher relative to the cost of um, energy, right? BTU is just a measure of energy, compared to other places in Europe and a city like Beijing. So, while they weren't that much higher in London versus Amsterdam, they were significantly higher in Newcastle. And as again, remember, that's just because coal was in Newcastle. And so coal was much cheaper there. And so it was abundant and it provided an incentive for firms to use that resource. So if we think about it, in the 1600s, we can think of our model as describing what was going on in Britain in the 1600s when the price of coal was relatively high and the price of labor was lower. Firms were using technology B, that was their lowest cost alternative. We know that point A would cost more. So even if that technology existed, firms wouldn't have used it. And, it's a bit of a chicken and egg question, but the fact is that the technology didn't exist and then firms didn't use it. But then when the price of coal falls, now there is an incentive to use technology A. And of course, the scientific revolution is chugging along side by side with the technological and capitalist revolutions. And so they're coming up with new technologies, new inventions. And now in the 1700s, technology A is cheaper than technology B, right? Because A lies with inside B at those relative prices. So we can think of, there might be a point like point A prime here that is cheaper, right, than producing at either point B or point A. But firms wouldn't use it because the technology did not exist, but it might exist in the future. So what's going on is, so we have this model, right, of what happened around the 17th and 18th centuries, right, where we escape from what we're going to call the Malthusian trap. But what was going on before then, right? We need some sort of different model to describe what was going on before, 1750 or 1800 and what was going on after that. And so we have this model that might work to describe what was going on after that, but we don't have the model that sort of describes what was going on before then. So in order to do that, we're going to take a look at what we'll call the production function. Hopefully that sounds somewhat familiar from microeconomics. And so production function just takes some sort of input, in this case it's going to be labor, and turns it into some sort of output, right? And in this case it will be grain. And so now we have this production function, and we can figure out the average product of labor, which is just total output divided by total input. And so you can see that what's going on is that as we add more workers, we always get more output, but our average product of labor is falling, right? So it goes from 1,000 kilograms per worker all the way down to 300 kilograms per worker, because these last workers are just not adding as much output as these first workers. And so one of the reasons for that could be the diminishing average product of labor, right? So it could be that too many farmers just aren't that helpful, It could be that the land that they're farming becomes less and less productive, right? The first farmers take the most productive land, and then farmers after that have to take less productive land. And so when we graph our production function here in this purple line, we can see that the average product of labor, which is just these rays here, the slope of these rays, is getting flatter and flatter or smaller and smaller. And so we can see that that's what we call the law of diminishing average product of labor. That is, we add more and more labor, but we keep everything else constant, so land or capital or energy, whatever, all of those other inputs constant. Adding more workers adds more output, but at a slower and slower pace. So let's just look at a couple points along our production function. So at point A, we have 800 workers and we have 500,000 kilograms of grain. At point B, we have 1,600 workers and we have a little over 700,000 kilograms of grain. And so we can figure out the average product of labor at both points, right? So at point A, it's just 500,000 divided by 800, or 625 kilograms of grain per worker. And at point B, it's 732,000 divided by 1,600, or 458 kilograms of grain per worker. And the idea is that the average product is falling because the marginal product, which remember is the amount that each additional worker produces, is falling even faster. And we can see the average product graphically by drawing the slope from the origin to whatever point along the production function that we're interested in.